Development of continental drift theory. The idea of continental movement has been with us since the middle of the 19th century, with the understanding of the driving force being relatively recent in the 1960s. The basic concept extends all the way back to the early mapmakers who noticed that the coastlines of Africa and South America had a remarkable similarity. As early as 1858, a French scientist, Antonio Snider Pellegrini, wrote that the Atlantic Ocean had formed when powerful forces broke apart a great continent. At that time, this idea was not given serious consideration by most geologists. However, evidence supporting this concept gradually developed from geological and paleontological observations in the continents of the southern hemisphere and India. There is great similarity between the animals of India and Madagascar, two land areas now separated by 2,500 miles of ocean. In order to explain this observation, an early idea was that the continents were joined by land bridges of granitic rock that later sank into the ocean's basalt crust. This idea also supported the Austrian geologist Edward Suess's work with the fossil plant Glossopetris, which he found distributed throughout India, South America, Southern Africa, Australia, and Antarctica. He felt that the presence of a land bridge connecting all these continental areas would explain the distribution of this group of fossil plants over such widely separated locations. He named this landmass of continents and land bridges Gondwanaland. Between 1872 and 1876, the British HMS Challenger expedition took soundings throughout the Atlantic Ocean, which revealed an extensive ridge running north-south down the middle of the ocean floor, roughly halfway between the American continents and Europe-Africa. Using these data, Frank Taylor in 1908 proposed that the continents had at one time been adjacent but had been pulled apart by tremendous forces, and that the central ridge, the Mid-Atlantic Ridge, was the site of this ancient boundary. Not long after Taylor's work was published, Alfred Wegener, a German meteorologist, presented his theories in his 1915 book on the origin of continents and oceans. He proposed that, at one time, all of the continents were joined into one huge supercontinent, which he named Pangaea, Greek for all the land, and that at a later date the continents split apart, moving slowly to their present position on the globe. He felt that the idea of land bridges was not wrong because it called for less dense granitic rock to sink into more dense basaltic rock, which he felt was clearly impossible. In matching up coastlines, he found that by including the continental shelves, the fit was much more accurate, and by doing so, large blocks of ancient rock called cratons, the oldest core of a continental landmass, were found to form a contiguous pattern across the boundary of South America and Africa. He also looked at other geological formations and saw patterns, such as the presence of ancient mountains in South Africa, which aligned with the mountainous near Buenos Aires in Argentina when the two continents are fitted along coastlines. Layers of sandstone, shale, and clay interspersed with coal in both South Africa and Brazil seem to match in sequence. Wegener's theory was so radical that it was not given serious consideration by most of the scientific community. In fact, he was subjected to ridicule and insult for daring to present his preposterous ideas. Although some of Wegener's information was off the mark, the largest part was accurate. But his theory's greatest weakness was his explanation of cause. He suggested that the centrifugal force of the spinning planet would tend to force the continents equatorward, and that tidal pull from the sun and moon might cause lateral movement. However, he did not seem very confident in those mechanisms, as he also stated that the complete solution of the problem of the driving forces will still be a long time coming. While in Europe and North America, Wegener's ideas were being attacked. In the Southern Hemisphere, some of his staunchest supporters were collecting data to support the theory of continental drift. But despite the evidence presented by supporters, most of the scientific community still did not accept the theory of continental drift. It was not until 30 years after Wegener's death that scientists of the 1960s described the seafloor spreading and plate tectonics that were the undeniable proof of continental drift.